Welcome to Julia Control Structures, Functions, Tasks, and Modules. Here's what we'll learn in this section. Julia Control Structures, Loop Control Structures, Functions in Math Library, Tasks and Coroutines and Channels, Methods, and Modules. I'll start with Conditional Control Structures. In this video, we'll look at our comparison operators, chaining conditionals and comparison operators, conditionals and shortcuts, if, else, and end, the question mark operator, and to begin with, and then their shortcuts as logical operators, vertical bar. Okay, we're now in Julia, and we have true and false. These values are represented as 1-byte values, 1 or 0, 1 for true, 0 for false. And these values, every time we make a conditional expression, they get evaluated, and we get either true or false from that evaluation, and then flow goes accordingly. So if this is true, we go here. If this is false, we drop down and we do this. So let's go ahead and take this. So here, x is equal to 2, y is equal to 1. So x is not less than y, so we don't do that. We drop down. Here we go, x is greater than y. So we actually do this, and there it is down here. Else we would have done that, which we didn't do. Okay, now there's two important things here. One is you can have as many else's as you want in here, all sorts of different conditions. An example might be, supposing you have a robot and you have a bunch of numbered commands for the robot. So we can just go else if is x equal to 1, is x equal to 2, is x equal to 3, and so on, in order to find out what command it is, and then go ahead and execute that command, whatever it is. It's called a case statement in that, treating all these different cases. Okay, another thing you can do is inside of an if, you can have another if. And inside of that if, you can have another if, and so on. So you could have these nested to practically any level. So these things can be nested. You can have lots of else ifs. And so you can have a very complicated structure out of this. Going on, so I'm going to go back to another prior video. We were talking about numbers that don't get exactly turned into, for example, the rational number 1/3, 1//3, and if you can rationalize 1/3 and get this. However, if that were a floating point, it would not be equal because this is a continued binary fraction. So down here we have 1 approximately equal to 0.99999, and that works as long as you have enough nines there. Where this wavy equals means approximately equal. The code for that is \approx, and if you do the ripple thing of continuing the command, it'll give you the wavy sign. Okay, or you can just take this, stick it in your own program. Okay, here we have one that's from the last video where we had 3.825, and we found out that was not equal to the rational number 153/40. So that would be false. However, this is true. Okay, you have to be careful of any real number, comparing it to a rational, comparing it to, or even to another real number that you may have more precision for some reason, like you've added something to something in it, and you think it equals something else, but it doesn't quite. So you have to be careful. Okay, that's where this guy comes in, and he's very useful. Let's go on. Here's another type of conditional that is borrowed from C. It's very simple. Let me just, first of all, copy it down. So here we have -2, and here it checks the condition x less than 0. Yes, it is. And so we do this right here. We assign -x to y. Otherwise, if it was false, we would assign x to y. X would get y. So essentially, it's doing the absolute value function. But this could be for any kind of conditional where you want to assign something depending on this condition here, this being the true assignment and this being the false assignment. It's very handy. Unfortunately, there's another one. I say unfortunately because sometimes these are misused, and misused a lot, and can be very complex the way they do it. And it's hard to see what's going on. This one uses a side effect of expression evaluation. What I mean by that is when you're evaluating an and condition, this is double ampersand is an and condition, and if this is true, then it goes on, because in order for an AND condition to be met, all the elements have to be true. If this is false, it would drop out immediately. So in this case, I have a negative number, and if it's negative, I want to set a positive. This is doing the absolute value function again. And so that's what it's doing. And so it'll only if this is negative will it do it. If it's positive, it'll just drop and go on. Okay. We have the same thing down here. We can do the same sort of thing. Here, x is negative, and we're taking not x being negative. You want to do this. If this is true, and this is false, a false and an OR, you have to go on to the next one in order to find out that you're going to pass the OR. And so whether or not you have to evaluate again. So then it evaluates this and assigns x to minus x. Again, you get a absolute value. I definitely don't recommend these, but you should know that what they are in case you run into them. But I think using a side effect of an evaluation function is, first of all, kind of dangerous. And secondly, I think it's obfuscating. It's making things less obvious. Okay. This one, and it did take the minus 3 and turned it into 3. And this one, it took the minus 4 and turned it into 4. Oops. Okay. It's weird, but it does obfuscate code, and I don't recommend it. It's a little bit more efficient, a little bit faster, and maybe somebody can find use for it in very deeply nested loops somewhere. Every nanosecond counts. Anyway, okay, but I put them in there because I think it's important to know them so you know them when you see them. Okay, now we're going to dig deeper into the AND and OR functions. In this case, there's the logical AND and logical OR again, and we can compound these. Is it the case that 3 is less than 5 and 7 is greater than 6? Well, that happens to be a true statement. I can just take these down and they'll give you a truth and give you evaluations. Okay, so this is true. Is 3 greater than 5 or 2 less than 5? Well, 3 is not greater than 5, but 2 is less than 5, so this is true. If either one of the conditions is true, this will be true. Okay, here's another AND condition. Is 3 greater than 5 and 7 greater than 6? Well, 3 is not greater than 5, so this is false. So the very first one here said it was false, and you don't have to go any further. Okay, so that's basically it. The OR function, either one of these is true, and the AND function, both have to be true. So you have a lot of other comparison operators. Here's your comparison operators. You have less than or equal, but you also have this guy here. Here's the code for it. Here's the char code, the Unicode. You have the same thing here for greater than equal, and for not equal, you have that. So you also have this, which is kind of weird, but some people like it. So the characters, if you want to use them, because it makes it a little bit closer to the math that you might be copying. So here I'm using them, and you can also chain these operators. This statement happens to be true. So if you just look at it, 1 is less than 2, 2 is less than or equal to 2, which is less than 3, which is equal to 3, greater than 2, which is greater than equal to 1, which is equal to 1, which is less than 3, which is not equal to 5. So it can be chained like that, and there's also exclusive OR. There's a special character for that too. If they're both true, it's false. If one's true and the other one's false, then it's true. If they're both false, it's false. So they can't be both true and they can't be both false. And one has to be true and the other one has to be false for exclusive OR. And exclusive OR doesn't chain very well. But here we go. Here's a very useful situation here. Well, here we have x equal to 1 and y equal to 2. And so we're checking to see if x is less than 5 and y is greater than 2. Well, that's false, isn't it? So let's just do that. Now this is true. This is a very useful one. Okay, so this being true, we have x that falls with the zone 0 to 1 because it's 1, so it's less than or equal to 1, equal in this case, and y is in the real zone 1 to 2. So it's equal to 2, so it's in that zone as well. So sometimes you want to check limits to make sure that all the variables that you were dealing with were in the ranges that they needed to be. Okay, so here's what we've learned. Boolean variables, comparison operators, logical operators, chained operators, conditional control structures, the if, else if, and else, the question mark, colon conditional, and the ampersand and then operator, and the or else operator. That's for simple conditionals, but sometimes they can make them very messy. Don't use them.